So hello everybody, and welcome to my presentation. And a bit about me. I'm Enrico, Italian, and Android developer, currently based in London. So let's step immediately in the agenda. So to what we are talking today. In this talk, we will mainly focus on 3 points. We will see exactly what is Zotto Compose, why declarative pattern is useful, and how Compose is optimized internally to run specific tasks. How we can benefit about this optimization in an already structured code base. And so we will talk about 3 most famous patterns, so MVP, Mvvm, and MVI. And then we will ask a question. So adapting Compose will also change something in our test environment. With this last topic, we will try to answer to this question, seeing together how we can test a Compose component using the new UTP testing platform. So a bit of historical things. Google UI Kit has been out since September 2008. So we are talking about 11 years ago. So you can imagine how legacy and complicated this code has become. It was, this UI kit was based on the imperative pattern. Imperative UI is a common paradigm. It involves having a separate prototype model of the application UI. This design focuses on how rather than what. A good example is the XML layouts in Android. We design the widgets and the component which are then rendered for the user to see and interact with. So again, we are giving an explicit instruction, and the system is more or less stupid. We know to tell it how to do it, right? For example, here is a complicated class that I think everyone have worked with, some adapter with holders. So we are specifically say to the system how to render a component. In Google I/O 2019, Google gave a great presentation about the declarative pattern, which is a paradigm that currently is used by Zotto Compose. It's not a new concept. It has been used for many years in many frameworks like React, etc. Even Google has adopted this pattern, for example, in Flutter. It's based again on the declarative programming, which is a paradigm that expresses the logic of the computation without describing its control flow. And many languages that apply this style attempted to minimize or eliminate side effects by describing what the program must accomplish in terms of the problem domain, rather than describe how to accomplish it. So what it means. In the imperative paradigm, we just say we have a layout that has some dimension with 3 children. Every children has some attributes, and then in these 3 children can be, for example, buttons with text. In the declarative way, we just say we have 3 buttons which has some text. So we just describe the outcome, and the system is smart, so you don't care how things are, done. This is, for example, a recycle view, and you can compare this approach with the previous one. You can see it's more compact. And so before start talking about architectural pattern and ask us how we can adapt Compose and if we can use Compose in our pattern, there are some things that we have to keep in mind. So first of all, we will talk about UDF, so Unidirectional Data Flow, composition versus inheritance, encapsulation, and stateless versus stateful. And in the end, we will mention a bit about how their composition is working. These concepts are very important to keep in mind because in an already structured code base, when we are emitting data, we should also optimize these practices in order to use the real power of Zotto Compose. So first of all, Zotto Compose, this framework is built off the standard of unidirectional data flow. A unidirectional data flow is a design pattern where the state flows down and the events flows up. So following the UDF, you can decouple composables that display state in the UI from the part of the application that store and change the state. And so unlike the legacy Android UI system, composable should be relative stateless, meaning that we are exposing a state and we are not changing this state inside the composable itself, right? So another concept that is very important, that Zotto Compose uses composition instead inheritance. In the old world, for example, we had a view class, a parent view class from which we was extending all the components, like, for example, image button, etc. When I first started learning Android, at the same point, I was trying to use an image instead a text for a button. So I found image button. I would say like, all right, so everything can be good. So I just converted it in XML. But 20 seconds later, everything is broke. I got a lot of compile errors because image button seems very close to the button, but they are two different classes. So with the composition, we can do this thing in a very fast way. We just, declare a button and use some modifiers in order to specify or attach an icons, etc. So in the end, building a UI with inheritance does not scale over space and time so far. Instead, saying a button is equals whatever text we would like to show with some icons, and with a callback is pretty much very straightforward and will scale in the future. So Zotto Compose has another important concept, which is the encapsulation. State encapsulation, to be precise. So we just expose state from the view model or from our state holder, and we are delegating to this tool that is called a remember, that we can talk later about, in order to remember what is the composable state, right? And Zotto Compose should be stateless and without side effect. While our goal is for our composable to be larger stateless, sometimes we need a small portion to be stateful. For example, remember the scroll state. During the recomposition, we don't want, for example, to lose these small states like, scroll position again of a recycle view. We can use tools like remember savable to restore our UI state during the recomposition. Managing state in Zotto Compose can be difficult sometimes, because again, we would like our component to be stateless without side effects. And if we need to manage the state, so to make the component a bit stateful, we need to use its proper API, which is the effect API. Like, for example, if we need to launch a coroutine or launch a suspend function inside the scope composable, we can use launch effect. We have a bunch of them, so I will not go in detail, but have a look on the effect API if you need to make your component not stateless. So, saying that, how state values are managed by Compose. State values in Compose that are going to change, like the one hosted in the mutable state, are generally referred as a snapshot state. The snapshot state is a thread safe. Due mutating state threads during different threads is very difficult, right? So Compose snapshot mechanism is very new in UI programming, and it allows you to work with multiple state in a safe way across multiple threads without race condition. So by default, mutation state policy is specified by this, so structural equality policy, What it means? It means that if the new state differs from the previous one, then the composable that we are writing will be recomputed, right? So compose ships with function to create state of generic data from the common observable types that are currently used in another application, like live data, flow, or several that are coming from React Java 2. So yesterday I followed a good presentation how to, they went very, very deep in the manner in which the Jetpack compiler is working. If you would like to know more about details of the snapshot system, I really suggest you to have a look to this presentation when the video will be published. And so again, recomposition, so which is an important topic to have in mind when we will have to talk about our patterns. So if your state will mute, our snapshot system will trigger the recomposition. To keep in mind, once we are thinking about this stuff, is that the recomposition can be triggered at any time and can be executed in parallel, right? This is one of the reasons why it's important not to do stuff like perform side effect directly in composables. And when we have, again, as I told before, we needed to use the effect API. So recomposition skips as much as possible, right? It means that when portions of your UI are invalid, Compose does its best to recompose this portion in the optimistic way, right? So it handles the recomposition in a very smart way. So if we have a nested UI, for example, and we have to change only one text, not all the three will be recomposed, right? So how this is working? This is working because of Jetpack Compose is internally used in a slot table that is built using the gap buffer. What is a gap buffer? A gap buffer is a dynamic array that allows efficient insertion and deletion operation clustered near the same location. So it is implemented in memory with a flat array, and this flat array, of course, is larger than a collection data that it represents. So let's see a bit in which manner it's working. So the composer, the Jetpack Compose compiler, is allocating in memory the data structure that we need. Now we just execute in the composable hierarchy in order to fulfill the array, and at some point our state will mutate, so we are going to recompose, right? So we reset the cursor to the top of the array, and then we go through the execution again. And we may decide that the data structure of UI has changed, and we want to make an insertion, right? At this point, we just move the gap to that position, and now we are able to do this insertion as well. The important thing about the gap buffer is that we are doing a bet, right? So when the recomposition is happening, right, all the operations are more or less are constants, right? Get, moving, insert, and delete are ODK, but moving the gap is ODN. We are making a bet to say that on average, not all our UI is changed, but only a portion of it. This is a good concept to keep in mind. For example, think about in Android how often we did the diff of different data in a good way. Think about, for example, when you are exposing different content in the recycle view. Currently, in the last year, we used the futils, right? So Jetpack Compose is doing this one for us already, right? So to keep in mind, apart how we are exposing state and how Jetpack Compose is calculating these differences when it's re-rendering the UI, is how we can expose state, right? We have the concept of due models, and currently we just introduce other concept that is, for example, the state hoisting, and is the manner in which we just hosting the state in the composables. And so with this in mind, we are going now to talk about our present code architecture. And keep in mind, as I said before, the unidirectional data flow. We are expecting 3 patterns, MVP, Mvvm, and MVI, very fast in order to see if are good to use compose. And in the end of the day, what we want a good architecture that gives us the possibility to handle all the linear flow of the application logic, a proper control over the UI and the asynchronous event, and a sort of predefined test structure, and a quick environment in which we would like and we can debug. So MVP, I'm going very fast here, is all the architectural pattern. Currently, everyone, I think, knows that the presenter is hosting an instance of the view, and there is a pinpoint between the presenter and the view, so the flow is not unidirectional. So this is not the correct pattern to use in a Jetpack-Compose. But there was, this guy made research how you can adapt MVP using view models and adapt this data structure to be used with Jetpack-Compose. Mvvm, as you know, is the most common and famous pattern that is used during these days. We just expose a data stream from the view model. The view is emitting user events, so we are reacting and we are changing and emitting other data flow. This is what we are looking for, right? So it's based on the unidirectional data flow, so Jetpack-Compose can be used very easily in this pattern. MVI, sorry, is a model view intent pattern in Android and is highly inspired by web frameworks like Redux. It's a new trend in terms of pattern, and the question, I will not go into the details of the pattern, but the question that I currently ask you here is, how do you efficiently perform partial state of dates from MVI from our render function? So the part from the reducer, when the state is changing, in which manner we can optimize this render function in order not to recompute all the view, but only partial part of this view. A lot of companies tried to improve this process, like Spotify. There is an open source library to calculate and render this change of the view in an optimal way. So Compose here arrive with superpowers, right? Because the render function, if you think we talked just 5 minutes ago, the differences of the two states of the views and the views is done internally, right? In a good way. So we had a clean architecture. We currently have a pattern that gives us the possibility to have a control over UI and the synchronous event. What we miss. Currently, we would like to have a predefined test structure and a quick debugging environment. So let's see together in which manner we can solve these two missing points in order to skyrocket our project. What is changing in our test environment using Compose? Well, almost nothing. The test pyramid should be always maintained, so we should always fulfill all the 3 layers, starting from the unit test, integration, and end-to-end test. As you know, with Jetpack-Compose, they released also the Jetpack-Compose testing API, which has a lot of similar things, very similar thing than the Espresso framework. We have finders, assertion, and matchers, and use it to, of course, find our views, matching our views with some criteria, and later on assert something. We have action in order to emulate the user interaction with our application. We have also the Compose and the Android Compose test rule, right? So what are the Android Compose and the Jetpack-Compose test rule? So our unit test rules that give us the possibility to test our component in isolation, think about the compose test rule, we can start a compose in isolation without the Android context. If we need the Android context, right, like for example, we would like to test and we would like to have access to our strings resources, we should use the Android compose test rule. And where compose content, of course, is hosted in an activity. And Android compose test rule and all the Jetpack compose SPI are already synchronized, right? It means that you don't need to synchronize our UI, but you can still use, for example, idling resources, or you can disable this synchronization. Let's say that you would like to test some animation, or you would like not to disable animation in your Jetpack compose. You can just disable this feature and make the progression of the system clock internally by hand, right? So if you would like to go deeper on this topic, yesterday there was another presentation, another talk that in which Dimitri presents all these API in a very well manner. So going very deep in every part of the Jetpack test of compose API. So there is another thing to say, that Jetpack Compose API can live without any issue with Espresso, right? So think about that you would like to test, for example, the interoperability of your application. You can use Espresso Intense with the Jetpack Compose API. So currently, again, we have the clean architecture. Okay, everything is handled by our pattern. We have a predefined test structure, so in which manner we can run our test properly. So let's see the last point together. Time ago, before Google I/O 19, we had, and we still have, a couple of issues running instrumented tests, because Android Studio was using the IntelliJ Android instrumented test runner. Instead, if you would like to run your instrumented test by command line, so with the Gradle plugin, Gradle was using its own implementation of the Android instrumented test runner. What it means? It means that sometimes, if you, for example, running your test with Espresso and in the emulator, it passes. And if you run it by command line, it can fail. And in which manner Google solved this issue? With the last, as I said, with the latest Google I/O, we have this new thing that is called the Gradle test runner, which is unify the two approaches, right? And in order to make your results more consistent between the two environments. So with this unified Gradle test runner, Gradle have also visibility not only on all your tests, but also on the device lifecycle. And with this, lot of improvement were done. And first of all, they have introduced these automated test devices. And what are automated test devices? If you would like to run your test by command line, right, you have to specify where you would like to run it. So automated test devices are a sort of devices, very light, so a sort of emulator that are very light, in which Google removed a lot of things, removed the system UI, a lot of Android open source application and services, a lot of things like Google product apps like Mail, Maps, Chrome, Messages, etc., in order to make your testing experience faster. Right? Just a side note here, automated tested devices, if you will use later on the snapshot feature, right, are not fully supported. Let's see later on in which manner we can do. So in which manner we can configure an automated test device. We can use, for example, this function in which we can just add an emulated test device that is currently a Pixel 2. But we can have also a group of test devices in which we can specify a normal device or a tablet. And we can run this test by command line, specifying also the use unified tester platform, because, of course, this one is experimental. We have another good thing that in Google I/O was introduced, was the emulator snapshot. So we can have and retrieve a snapshot if the test is failing, accessing directly from our test metrics. As I said before, this emulator snapshot is not fully working with our Android tested devices, virtual devices, sorry. But we can see later on in which manner we can fix it. So in which manner we can configure this feature? We just, we can go to edit in which manner we would like to run. We just support currently, we just enable the emulator snapshot. We can, explicitly say how many snapshots we would like to take. And instead, on Gradle, we just, added in the scope fashion of the emulator snapshot, we just add the emulator testing failures and the max snapshot for testing failures. So now we can see in which manner we are running this test. Currently here is I wrote a small test in which we just asserting that the condition is failing, in which manner we can reload and load in the snapshot in order to debug that the condition is failing. So here, as you can see in the test matrix, the test assert is failing. So currently, I just, let's see if it's working. Yes. I just reload the snapshot, and as you can see, exactly, I'm just debugging in the point in which the condition is failing. And the emulator state is just currently reloaded. It's the same from the command line. Currently, I just run the test. The test is failing. Here is a bit slower. But as you can see, the test is failing. And the problem, as I told before, the emulator snapshot system is not working very well here. But what you have to do manually go to the folder in which the test result is saved and just loaded, and just loading from the menu. And as you can see here, the snapshot is reloaded, and it is exactly in the same manner in which you was doing from your emulator. You can reload the state, and you can debug. A second. All right. And you can debug exactly in the point in which your test is failing. So a bit of recap right now. And we talk about a different concept. We touch a lot of good points and dark points. Currently, we have a clean architecture. If we have a clean architecture, we have, of course, a control over a UI and a synchronous event. And it's very important also to have a good test structure and test suite in order to UI integrate and end-to-end test our components. What we missed in the past was also a good environment in which we can run and debug our tests, both in the real devices, plus in our maybe a continuous integration, so now to link everything. Currently, this is working in Android preview, will be released later on. So I think that currently we have a good environment in which we can skyrocket our project. And with this last slide, the presentation is finished, and I really thank you for your presence.